guys, Jeremy here with Simple Little Life, and welcome to another edition of Tool Time Tuesday. This week I'm just going to show you the milling machine that I use in my shop. Now, a question I get asked a lot is, does a knife maker need a milling machine? And my answer to that is absolutely not. You really don't need a milling machine. A good drill press would be, purchased long before a milling machine. Now, if you would like to get into folding knives and locking knives and stuff like that, friction folders not so much, but anything that's going to have locking mechanisms like that, then yes, you're going to want a milling machine. Having said that, a lot of these less expensive ones, the Grizzlies, and the one I have is a Craftex CX600, even those aren't ideal. If I were to actually shop for a milling machine and went out to buy one, I would look for something like an old Bridgeport or something from the 60s, something that's got a lot of girth to it and a lot of weight. Just like an anvil and blacksmithing, the more weight you have, the better. Same thing, when you really start using these little milling machines, you really notice their lack of girth. When I started my millwright apprenticeship, I think I was 17 years old when I started using a milling machine a lot, probably about 30 hours a week for a few years, 3 or 4 years. And so I have a lot of experience on a milling machine, and even the ones that we'd bought for work, they weren't really high-end ones, but they were big. They had a lot of meat to them. And thinking about my experiences with those and the depth of cuts that I would take, the different type of cuts, the different material, this thing's almost a joke. Really good for aluminum and synthetics, like your handle material if you want to do some decorative work there. You can use it for putting like jimping on a knife, on the spine of a knife, or little choils in it. But honestly, they're just not that great. They're really a lot of compromises for the price to make them affordable for what you get. So I'm not convinced that I would necessarily go out and buy a milling machine. I was actually looking for an engine lathe, and I bought a lathe from a gentleman in Calgary, and he had cancer. He was in full remission, but after recovering, he really didn't have the energy he used to. So he was getting out of hobby machining that he had done in his garage, and when I went to buy the lathe, I got a really good deal on it, and he said, "Do you have any interest in a milling machine?" And I said, "Well, how much do you want for it?" And he told me that if I can carry it into my truck, I could have it. And I thought he was joking. I said, "Yeah, right." He goes, "No, I'm serious. You can take it away. Either I have to list it and sell it," which he could have done. But he said, "If you can take it today, it's yours. Just have it." So he had a lot of fancy like vices and rotary vices. I think I got 5 or 6 different vices with it when I bought it. All kinds of custom tooling he had for it, end mills. Really, I haven't bought a single thing for my milling machine since I got it for free. So that was a pretty hot deal, and because of that, I've tried to look at processes that I could incorporate my milling machine to, and some work, some don't. Even a lot of the little tiny Spanish notch that I put in my blades, I still prefer to do that with a file because it's faster than setting up the blade, locking it down, putting in the cutter, and milling it in my milling machine. So it's one of these things. It's a fun tool to have. It's a nice tool to have. I would say what I've found to be the biggest advantage of having a milling machine is actually I can make different jigs and fixtures for knife making. I don't necessarily use it so much on the knives, but just to make things is really handy. Just as an example, one thing that I made was a Kydex press for making a little standoff for a belt loop. You could certainly do this. I'm actually going to do a video on this probably, but do it with a router. But a milling machine, super nice, and it's just wood. So that little milling machine handles stuff like wood and everything like that great. So let's head over and take a look at the milling machine. I'll kind of explain to you a little bit about milling machines, really basic stuff. Okay, every time that I shoot the intro for Tool Time Tuesday, I keep forgetting to feature a viewer's knife. So after I've shot all the video footage for this video, later on in the evening I'm coming back and Erwin, I didn't forget about your knife. These are the knives that Erwin made. He's a knife maker from Belgium, and I would definitely say he's doing a great job getting into knife making. Hope you're having a blast, Erwin. Thank you for sharing your pictures. And for all you who have sent pictures already, I am going to feature them in Tool Time Tuesday. I may also do a viewer knife video, but I'm featuring them in the order that I've received them. So I've got a lot of them. Keep them coming, guys. This is so great to share what we've made with each other, and I like to see it, and I'm sure all you viewers like to see what other guys are making too. So thanks for sharing, guys. Keep those coming. Now, back to the milling machine. All right, guys, let's take a quick look at a milling machine. So this here is the Craftex CX600. It is a 7-inch by 20-inch capacity. And what that means is that its table is 7 inches by 20 inches, and in theory it should have 7 inches of travel on the y-axis and 20 inches travel on the x-axis. What do we have here? Really, basically all it is a glorified drill press. this one especially. The spindle is a little heavier than on a drill press because it's designed to take some side loading, whereas your drill press, really the only load is an axial load going up, an axial thrust load while you're drilling, whereas this is designed to take some radial thrust loads, moving the spindle this way and that way as you're cutting through your machines, as you're cutting through your material. So we've got a drill press spindle here. This one is Kaulitz with an R8 Kaulitz, and I'll show you those in a minute, kind of explain what's that about. That's a fairly small size Kaulitz, and I'll show you those in 1 second. So really, right now I've just got a Jacob's chuck in here, and you've got this, just like a drill press, goes up and down. Like most drill presses, you can move the head up and down, or like this. Some of the bigger ones, you can move the knee. Now I guess this would be considered the knee. If you have a floor standing milling machine, you've got the base that sits on the ground, and then the table would actually be part of the knee. A lot of those, that can be adjusted up and down as well. Not so with this one. And then we've got these dials here. The dials on either side of this will simply turn this table in the X-axis, and then on this side we can turn our table back and forth on the Y-axis, and that allows us to cut different slots. You can flatten surfaces, smooth surfaces out. Really, it's a drill press that you can rigidly hold a piece and manipulate the bit across the piece. So definitely a handy tool, but a few limitations with this one, and something to consider if you're looking to possibly get a milling machine. This one's sized at a 20" by 7" That is, in theory, there should be able to work on a piece that's 7 inches wide by 20 inches long, and that's a bit of a misnomer because it depends on the process that you're doing to it and the type of cutter you're using. You might not be able to work on a piece of that size even though your machine says it can. Same thing with engine lathes. Like my lathe is a 10 by 22 inch, so in theory I should be able to turn a 10 inch diameter by 22 inches long. Depends again what we're doing to it. I might not be able to fit a certain cutter if I want to knurl, the outside of a 10-inch diameter. You might not be able to. So when you're buying these machines, really know that the size of the machine you're buying, you're not going to want to machine anything that's that size. And if you have a part that's 7 inches by 12 inches, I would suggest going at least 25% bigger when you're looking for a machine that will handle that size of workpiece. So that's just something to keep in mind, consider. This one here is a DC motor, so it's 110 volt, converts to DC. This is only a 600 watt unit. It's got a variable speed on here. Let me grab the camera here, I'll show you. Okay, so this one is a completely manual milling machine, meaning that any adjustments are by hand. Some of them have motorized feed to them, which is nice. You get a much more consistent cut. For me, when I'm machining slots or something like that, or anything really, if I'm moving the table, I'm doing it by hand. And one thing that really affects your surface finish is if your hands aren't quite steady. So if you can keep a nice steady motion on there, it's going to help. But if I'm like this, you're really actually going to see it in the finish that you get with a milling machine. So here we've got our little variable speed. The reason this one's easy to get as a variable speed is because it is a DC motor. The motor's actually right in here. Put this on. And so I'll fire it up here. And right now we're at, we're in high range. So in theory this is about 100 RPM, and it'll go all the way to 2,250. Or thereabout. And it has a reverse too, which is nice. Although most cutting tools you get will cut in the forward direction only, it is a nice option. And then 2 gear ranges. So to change the gear range on this, it's actually just moves the drive gears. You need to do it while the machine is running, and all I do is simply turn this dial right here. And now I'm in the low gear range, which will give me a range of 50 to 1,125 RPM. Now for machining stuff like aluminum, the cutting speed of aluminum can be really, really high. It's about 400 surface feet per minute. So if I'm doing like a 3/8 or 1/4 inch slot or something, this machine won't get me up to the speed that I need to properly cut aluminum, but it does all right. And again, being fully manual, I can raise and lower my quill here. Also, I can engage my quill. And then I've got this little digital readout here, and I can set this for thousandths of an inch or millimeters, and this will actually move my quill up and down quite precisely. This is a nice little touch. Rather than using a dial, a lot of people just don't know how to read the dials. They've got the vernier scale on them. on the knobs there. It is nice to have this here as well. I don't have a digital readout on either the x-axis or the y-axis of this machine, and that would be a nice feature, but like I said, I've spent so many years using milling machines that I really have no problem with these dials here and figuring, you know, exactly how to set stuff. And then these dials, what way is, say if you touch, you know, you're gonna have a starting point, you want to go a certain distance, you simply move this and it's a friction fit to the wheel, and so you can mark 0 and then move whatever the distance of cut you'd like to be. I have that same thing on the y-axis here for moving this in and out. A few tips when you're using a milling machine is, if you want a really great cut, you need to make sure everything is as tight as possible. That will help reduce tool chatter. Coolant's a good thing to use. I just use, like for all my aluminum, I use like an A9 aluminum cutting fluid. That makes a big difference. Obviously this machine is quite small. You can set up a coolant system on it. It's got a little drain tube in the table here. I just don't have the means to do that. To properly do that, I should shroud this whole thing, make a sheet metal shroud around it all, and then, you know, you need the pump and the sprayers, and that's all relatively inexpensive to add. I just don't have the space to do it, and as well, in my shipping container shop here, in the wintertime, this thing gets really cold, so I've got it next to my stove. That heats this place up really quick, and I can get this warmed up and use this in the winter as well. But really, what you'd like to do, some of the key things when you're machining, is keep everything tight that you can. So say this is the, you know, the adjustment for the head up and down. Always, once you're done setting the height you want, lock it up tight. That'll help you have a better cut. And say if I was machining in this axis only, I don't need any adjustment here. I should actually, there's a locking nut under here, 2 of them. 2 locking levers. Lock that up so this can't move, right? And that will make sure it will give me a more consistent cut, as well as depending on the diameter of the cutter, the style of the helix and the teeth and all that stuff. If you don't have this axis locked, you can be cutting and your table will actually move, and you'll end up with a cut that starts going crooked on you. So I would say probably one of the most basic, most important things when you're using a milling machine, lock everything up as tight as you can get it. Obviously, if you're moving this axis in and out, that one needs to be free, but everything else should be locked up. And that's one of the things that's so easy to forget when you're setting up a new process or something. You just forget to lock it, and you're wondering why your cuts are looking terrible and you got a lot of tool chatter. Just lock everything up. Real basic tip, makes a huge difference. And what else could I really tell you about this? I guess when you want to get a really great accurate cut, and I haven't had a need for it yet, you can tram the head. That's a process where you put a bar in here, and there'll be two dial indicators on either arm, and you can see exactly how square your tool is set up, and these are fully adjustable. So I can adjust the tilt of the head a little bit, adjust the belt. There's all kinds of adjustments on it. Most of the stuff that I do not need that, and so I haven't done that yet, but I probably should. It's a good practice. You can see here we've got like a metric rule, graduations on here, kind of help a bit. So on the table of a milling machine, you've got these T-slots in here, and that is really handy because it allows you to do all types of different things. For instance, this vise, I've got these C-clamps machined to the exact same distance here, and I've got those locked really tight. So when I just drop these into the slots here, I know that this vise is parallel with the bed of my milling table, so I don't have to line it up. You know, if you're trying to machine a groove in here, and if I just had this vise free on here that I bolted down, I should actually take an indicator and put it, you know, hold it in the drill chuck and run it along here so I can make sure that I get this perfectly straight. But these allow me to just drop it in there, and it's a really nice precise fit. So within a couple thou over about 4 inches, this stays true, and that's plenty good enough for me. Also, with a milling machine, these are very inexpensive to get. These are just different sized bolts, and then you've got your T-nuts that slide into the ways, or T-slots on your milling table. I guess they're not ways technically. So they'll slide into there, and then you've got, you know, your nuts that you can use. They're double threaded on both ends. You put those in there, and then these locking bars that would clamp your piece on one side, and these step blocks. I don't know if these are actually called step blocks. I forget all the proper terminology, but I'll set this up so you kind of have an idea of what you do. So really like that, and then we can put our nut on top, and now we're locking this down. This isn't going to move. Pressure is being applied with our nut here, and we can hold our workpiece down that way. That's a very slow way to do it, but excellent if you're just doing custom one-off pieces. If you're going to set anything up where you're doing multiple parts, you're going to want some type of a decent vise. Even a regular vise is good for, you know, any machinist vise is really handy to have. Like I said, when I got this thing, I think I had 5 or 6 different vices, so really cool little tool. Right now I just got a Jacob's chuck in here, and this is a R8 Kaulitz. And what that means is that there is a little collet in there, and it's a particular size to this machine. Any tool that I buy needs to be able to mount to this with an R8 size collet. Now that's a pretty small collet, but it's nice because if I order any parts off eBay or yada yada, it's kind of a standardized taper collet system, so I can just order anything that's an R8 and it's gonna fit on my machine. I'll just take this Jacob's chuck out of here and I'll show you how these collets work. On this one I've got a spindle locking screw. You can use like a spanner wrench. The gentleman that I bought this off of, he kind of custom made this fancy little thing. It works pretty good. So I'll simply hold that there, and then the very top of this spindle is a threaded rod that runs through it, and that is what threads into your collets and pulls them up into the taper to lock your tooling. So now it's loose. We'll undo those threads. You usually want to kind of be somewhat careful. You don't want to bang this taper around too much. And then it drops out like that. So here's a keyway in here. There's an internal key here that lines up with that. And then obviously this is the R8 size taper, and it wedges in there, and that's what properly centers and bites and grips your different collets. Now I'll show you what the other collets look like that you actually insert cutters into. Alright, so these are R8 size collets. All they really look like is this. So your cutting tool would go into there, and you'll notice there's slots machined into the edges here, and that allows that to move in and out. There's all very precisely ground, and as it goes up into the taper, that's what actually locks your cutting tool. These work really, really well, and anytime I'm looking for an end mill or different cutting tools, obviously I need to make sure they work with the size of collets that I have. Now this machine comes from everything from a 1/4 inch to up to 3/4 inch collet, and I would say 3/4 inch is getting mighty big for this machine. Even if you're doing a cut that's of any depth in aluminum, my little milling machine there does not work all that well for that. And here's a small collection of end mills. For them, there's the 2 and the 4 flute. A few things to keep in mind. Usually these 4 flutes, they will not drill or bore as well as the 2 fluted ones. A lot of them are missing the little cutting surface right in the center, so these are more good for an application where you're going to be side milling. Whereas if you need to actually do any plunge cutting, like boring down and then machining, then you're going to probably want to use the 2 fluted mill. However, they both do work. And so I've got everything here from, what is this, a 3/4 inch by 3/4 inch shank, all the way down to 3/16 by 3/8 inch shank. So it's a 3/16 diameter cutter, and the shank is a 3/8, so I would need to use my 3/8 collet to hold this in place. And then also there's lots of different types of cutters, and I'm hardly showing you any of the stuff out there, but even these ball-nosed cutters, or round nose end mills. These are what I machine the slots in the aluminum sanding blocks. This would be a 3/8 by 3/8. And these things are really handy. They work quite well. These are a lot of fun because you can do a lot of decorative work on the blades of your knife. And then you can get into all kinds of different tools. I don't use these much. These are fly cutter tools, so you'd mount your cutting bar in there, and what this will allow you to do is cut a really large diameter. Really good if you're just trying to very lightly smooth and flatten a surface. As long as you're fairly well set up, you can get a really nice, precise, flat machine surface with these. And then here's another style of boring head for an R8 Kaulitz. So again, we have the R8 Kaulitz here. That's the part that's particular to the machine that I have. That's the important part when you're buying tools, that you know what size your Kaulitz is. And this allows you to put different boring bars in, you know, if you wanted to bore out an engine. Not that I would, you know, cylinder of a dirt bike or something. Not that I would ever do that on this machine, but this gives you some different options for different tools and stuff as well. I really don't have a lot of weird and fancy tools for my milling machine, but you know, a simple set like this gets you through a lot of very basic processes. And then the ball nose cutters, I really like those too. Alright, so there's just a really quick, really basic look at these small tabletop / consumer type milling machines. They certainly are a really nice addition to your shop, your garage. However, I think that if you're considering one of these, you just need to understand that they are somewhat limiting in the fact that they're small and they're light. You can't expect to throw a piece of steel on there and just start cutting and have chips flying all over the place. These just don't work like that. For something like that, you'd probably want to save up for another year or two. Try to find an older vintage machine that's still in decent condition, because even though, you know, the size is going to be a little bit bigger, they're just much heavier, and the original manufacturing specifications are a lot better on those old machines than they are on these. These are kind of like a consumer / econo type way to get into milling. Having said that, all of your basic milling functions are there, and this is absolutely one of the cheapest ways to get into it. Anyways, I hope if you're considering a milling machine for your shop, something like this might give you a little bit of food for thought. And thanks for watching this week's edition of Tool Time Tuesday. Cheers.